Imagine falling toward a black hole. You see the universe warp around you. Time slows to a crawl. The laws of physics begin to break. But what actually happens next? Science has answers, but also terrifying gaps in our knowledge. In this video, we're going inside a black hole to explore exactly what science says, and what remains one of the deepest mysteries in the universe. Buckle up, this journey will bend your mind. Hey everyone, welcome back to the channel. Today, we're going on a trip to the most extreme places in the universe, black holes. We'll break down what modern physics says happens if you fall in and where our theories collapse. From event horizons to singularities and quantum mysteries, let's figure out what we know and what we don't. First, what is a black hole? At its simplest, a black hole is a region of space where gravity is so strong that nothing, not even light, can escape. Einstein's general relativity predicts them as solutions to his field equations. Think of them as the ultimate gravitational traps, formed when massive stars run out of fuel and collapse under their own weight. The boundary of a black hole is called the event horizon. This is the point of no return. Cross it, and you're done. No signal you send can get out. But what happens inside this boundary is where things get truly strange. Let's say you're an astronaut approaching a stellar mass black hole. First, you'd see a spectacular light show. The black hole's gravity bends light around it, creating an accretion disk that glows incredibly hot. You might see the universe behind you distorted and duplicated as you approach the event horizon. Then comes spaghettification. Near the event horizon, gravity isn't uniform. Your feet feel a much stronger pull than your head. This difference in gravitational force would stretch you out like spaghetti. If for small black holes, you'd be torn apart before you even reach the horizon. But here's the twist. For supermassive black holes, the tidal forces at the horizon can actually be weak. You could pass through without even noticing anything immediately. That's right, you wouldn't feel the boundary at all. But what happens next? Once you're inside the event horizon, classical physics says your fate is sealed. You must fall inward. There's no escape trajectory. And where are you going? To the singularity, a single point of infinite density where our current physics breaks down. Einstein's equations say the singularity has infinite curvature of space-time. But infinite isn't really a physical answer at S, a sign our theory fails here. This is one of the biggest gaps in physics. We can describe space-time all the way up to the singularity, but not at the singularity. Scientists think we need a theory of quantum gravity to truly understand what happens. But no one has that complete theory yet. String theory and loop quantum gravity offer possibilities, but no final answer exists. And there's another mystery. When something falls into a black hole, where does its information go? According to quantum mechanics, information can't be destroyed. But black holes seem to swallow everything irreversibly. Stephen Hawking famously showed that black holes are completely black. They radiate energy and can eventually evaporate. But this radiation is random. It doesn't seem to carry information about what fell in. So if the black hole eventually evaporates completely, where did the information about the things it swallowed go? This is the black hole information paradox. It pits quantum mechanics against general relativity. Resolving this paradox is one of the biggest unsolved problems in physics. Physicists have come up with some wild ideas to solve these mysteries. Maybe information is stored at the event horizon in a kind of holographic whale, like a 2D surface encoding 3D data. Or perhaps black holes don't have a singularity at all, but a quantum structure called a Planck star. Some even suggest black holes might connect to other universes or act as wormholes. But these are just theories. We don't have direct observational access to what happens inside a black hole. No experiment can see past the event horizon from the outside. It's the ultimate cosmic censorship. You might wonder, why do we care about what happens inside black holes? Because black holes are the perfect testbeds for the deepest laws of physics. Where relativity and quantum mechanics collide, we have a chance to discover new physics. Studying black holes could help us find a unified theory of everything. In fact, black holes aren't rare monsters. They're everywhere. There's a supermassive one in the center of our own Milky Way, Sagittarius A*, with over 4 million times the mass of our Sun. Understanding them means understanding the fate of stars, galaxies, and maybe even the universe itself. So, what happens inside a black hole, science says? You cross the event horizon with no turning back. Fall toward the singularity where our physics breaks down. But beyond that, we don't know yet. That's the frontier of modern science. It's humbling, it's thrilling, and it's why physicists keep pushing the boundaries. If you enjoyed this dive into cosmic mysteries, make sure to like, subscribe, tell me in the comments. What do you think happens inside a black hole? Thanks for watching and see you next time.